Alrighty, class, just checking that my mic's on. All right, so we're gonna go over lesson 6 quickly. So when we start this off, we're gonna be talking about volume and surface area of composite figures. When I say composite figures, I basically mean the volume and surface area of two or more figures joined together. Two or more shapes would be the better word we'll use there, shapes. Two or more shapes. So like I can take two rectangles, I can take a rectangle and a sphere, just depending on whatever it might be. So two or more shapes put together, right? All right, so I'm just going to erase that because that's not really important. All right, so we're going to start off, and just remember that for surface area, you need to subtract the parts of the shape that are included in the formula, but not actually in the compound shape, right? So sometimes you might have 4 sides in a rectangle, but that rectangle might not actually have 4 sides. So you just have to be careful with that. So I would always say, try to follow the thing that I'm going to do right now instead of relying solely on the formulas. Rely on the formulas just for your basics. But this is more thinking about the shapes and what they are actually making up. So when we're determining the surface area and the volume, I'm going to start off with the volume just because I personally find that a little bit easier, and then surface area gets a little bit complicated. So I'm going to have to erase my shapes in order to go over that with you. But right off the bat, let's split this up into 2 shapes. So I'm going to split this up into a box, 2 boxes like that. Right, so I'm going to split this up like that. So I'm going to call this the blue box, box 1, and I'm going to call this blue box, this green box, box 2. Right, so I know that the total volume of this thing is going to be volume total is going to equal V1, right? So the volume of box 1, which is the blue box, plus the volume of box 2, which is the green box, right? Need to do a little bit of investigating here and say, all right, so I have 60 is going to be my length here, or my height. We'll say that's my height, right? It's going to be my height here. I know that my width is going to be this bottom portion, right? And how I can find that is I know the entire bottom portion is 80, and I know that up until here it's 60. So I can determine by doing 80 minus 60 that this is going to be 20, right? And then I know that this entire length is 60, and I want to find out what this top length is, right? That top length is very similar to I want to find out what this is, this going across. So I'm going to change this from not a black pen. What this is going across, I know that this going across is the same thing as this going across and this going across, so it's going to be 10, right? So I have height, width, and length and width, right? So what I'm going to do is I'm just going to go put in my stuff. So for my blue box, my length times width times height is my volume, right? And it's plus, for my green, I know that I have this right here, right? So that is 60 because it's right here at the top too. So that's 60, right? I know this is 10, right? And I just want to know what this is. So I know that all of this together is 60, right? So it's safe for me to assume that if from here to here is 40, whatever's left over is the spot from here to here. So that's going to be 20, right? So I'm just going to go put in my dimensions of that box. So it's going to be 60 by 20 by 10. Right? Or I'm just going to put this in the formula. So it's going to be the length and width of the green. Length, width, height. Right? I don't know why this is moving so much. So length, width, height. So my length for the first one is 60 by 20 by 10. And then for the green one, it's just going to be 60 by 20 by 10. And by some miracle, they happen to be the same, right? But I know that the inside box is 1200. The blue box is 1200. The other box is also 1200. I'm going to add those two together. I'm going to get 2400 meters cubed. That's my volume, right? I'm actually going to move this all to the side. And the reason I'm going to do this is because I actually need to go and I need to erase quite a bit. Right, so I'm just going to move this to the side. I'm going to make it smaller, but we know that it's 2400 is the volume. Okay? Now, I'm going to erase this all. Because we need to now find surface area. And surface area is when this starts to get complicated. So I could go in and find the surface area of each box, but the reality of the situation is I can't do that. There's no surface area for this type of shape, right? So what I need to do is I actually need to go in and find the shape or the surface area of each different box that I have here, right? And we can do that. It's just going to take a lot. So what I'm going to do is I'm going to try and color code all these boxes so that we have the most optimal situation. And I'm going to find the surface area of each box individually. And then at the end, I'm going to add everything all together. Because for me, that makes the most sense, right? You want to keep it as streamlined and as efficient as possible. So let's go in and do this. Okay, I'm going to start off with my first box. And I'm going to find my first blue box that we had to start with. So I'm going to just go here. Sorry about that. Just going to go in. I'm going to draw my box in. Right. Let's find the surface area of that box. I know there's that box in the front and there's an identical box just like it in the back. Right. So I have two of those boxes. So I'm going to say surface area is equal to 2 times 60, and I knew from before that this was 20. 60 by 20. I'm just going to go put in the numbers that I already knew from before, just so that we have them. Okay, so this was 20. We had determined this was also, I believe we had determined this was also 20. And I think that was it. And if we need to, we can come back and look. Okay. So you have 60 times 20 for that first, those two blue boxes. They're off the bat, they're done. Let's move on, right? Now I'm going to come back up to the front and I'm going to use my pink pen. And I'm going to say, all right, I want to find out what this box is, right? And this box has a twin right in the back as well, right? They have a twin box. So there's going to be 2 of those, right? And I knew that this was 60 and then I knew this was 20 from before. So my surface area is going to be 2 times 60 times 20, which happened to be the same. So you could have done multiplied by, but I say do it this way. It makes more sense. Okay. You could have done multiplied by 4, sorry. All right. And then I'm going to move on. I'm going to say, okay, what other boxes do I have here? So I'm going to move on and do this box over here. And I'm going to do it in green. The small little box here, right? It's 10 by 20. So 10 by 20, right? And I only have one of them there, but if I look closely, I actually have another one here, right? Because when we did our math the first time, we found that this was 10, right? And that this top part was also 20. So we're going to do SA, they're both the same. They're both 2 times 10 by 20. Alrighty. Oops, I should put that in green. And this is why having these colored pens is always useful. Just helps you keep track of what you've done and what you haven't done, right? 10 by 20. Okay. Now I'm going to move on. I'm going to try using an orange pen. And then I see this box right here, right? So I have this box right here. I'm going to go, it's kind of like playing that game, like how many shapes are in the box, right? So we know we only have one of those. We don't have any more of those anywhere, so we're just going to put that one in. 10 times 40, right? And if we look down, we'll see that there's actually another box right here at the top. We have this box right here, right? And that is 60 by 20, right? So SA is equal to, or sorry, 60 by, it's the depth. So it's going this way, so that's 10. So 60 by 10, right? And then if I scroll down, I've hit these 2 boxes, right? I did that one, I did that one. And then, oh, I see a little box over here in the corner that we forgot, And you just want to make sure you got all the sides. So I have that one box over there, the yellow one, and that one's going to be surface area is equal to, that's 60, and then this is 10, so 60 by 10 as well. Okay, so I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I was just counting and making sure I had all my sides. So I had 1, 2, 3, 4, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I got all of them. All right, awesome. So now we're just going to take all of these and I'm going to add them together. So what I'm going to do is first, let's find out what each of these values is. So I'm just going to add them. Right, let's go in and find what each of these values is. So I know surface area is the sum of all sides. So I'm just going to do it here. Right, so let's go in. 2 times 60 times 20. 60 times 20 is 1200 times 2 is 2400. And I'm quickly just going to go and do these maths. Right, so 2400 here as well. 10 times 2 is 200 times 2 is 400. Right, 10 times 40 is 400. 60 times 10 is 600. 60 times 10 is 600. I'm just going to go in and add these all together. I have 2400 plus 2400 plus 400 plus 400 plus 600 plus 600 equals, I missed something. See, and that's why we double check our math always. Oh, that's what I missed. I missed this blue box at the bottom. How could I have forgotten that? I missed this box right here at the bottom. Right? So at the bottom, we need to add that blue box. There's only one of them. So surface area for that is equal to the entire length of the bottom is 80 times 10. Right? So we need to make sure we add that into our calculation as well. Equals 80 times 10 is 800. Sorry about that. So I'm just going to go back. 24 plus 2400 plus 400 plus 400 plus 600 plus 600 plus 800 is going to give me 7600 meters squared. Okay, so therefore my surface area, or I'm not going to say my surface area, I'm going to say surface area, therefore, and that's what these dots mean, just therefore, surface area is 7600 meters squared, and volume, which we calculated up here, was 2400 meters cubed. Is 2400 meters cubed, and of course you're just going to draw in a nice little circle. Okay, so moving onwards. So we have this shape. This is a pretty bad representation, but it looks like a sphere on top, or half of a sphere on top of a cylinder, right? So it's asking us to find the volume and the surface area. I always like to start off with volume personally, just because I find it easier, right? So volume is equal to the volume of the cylinder, right? Because you want to know what the volume of the cylinder is, plus half the volume of the sphere, because you only have half the sphere, right? So it's part of it's missing, half the volume of the sphere. Right? So let's just go find our volumes. Before we ever find volume of something circular, we want to find the radius. So I know the diameter is 10, so radius is going to equal 10 divided by 2, which is going to give me 5 meters squared. That's my radius. So let's just start plugging numbers in, and then we know 6 is my height. So volume equals, or volume total equals, volume of the cylinder. I know from my calculations before that volume of a cylinder is equal pi r squared times height, plus half. I know that from the earlier lesson, 4 pi r cubed divided by 3 is the volume for a sphere, right? I'm just going to start plugging stuff in now. So pi times 5 squared times 6 plus half 4 pi 5 cubed divided by 3, right, is going to give me 25 times 6 times pi is going to be 471.238. So I'm just going to write it as 24 plus 5 cubed is going to be 125 times 4 pi is going to give me 1570, and then divide that by 3 is going to give me 523.5987756, and times that by 0.5, which is just half, is going to give me 261.8. And I just did that all in my calculator because I wanted to keep as many decimal places as possible, right? Then I'm going to add these two together, and I'm going to get about 733.0 meters cubed. Okay, so that's the volume, that's the total volume. All right, again, like I said, surface area is always a little bit more complicated. So it's going to say surface area. We want to find the surface area of the cylinder plus the surface area of half the sphere. So there's a few things that we need to take into consideration here. Because the top part of that cylinder is covered, remember yesterday or the last lesson when we were talking, or in lesson 3 when we were talking about that cup, right, and how the top circle is actually missing. So when you're finding the surface area of the cylinder, right, when you're finding the surface area of the cylinder, you're actually going to ignore this top portion, which means that you'll only have to find the surface area of the circle down here plus the lateral surface, right? So we're going to put that in. So we're going to say the surface area is going to equal the surface area of the cylinder plus half the surface area of the circle or the sphere. Half surface area of sphere, right? So let's find the surface area of the cylinder. Like I said, you only have, so I'm going to put this in this red, surface area of cylinder. It only has one side. So you're going to take the area of the base, which is going to be just pi r squared, plus the area of the lateral surface, which we know is 2 pi r h. Okay, and let's just put that in. Let's put in the numbers. Pi times 5 squared plus 2 pi times 5 times the height, which was 6. Okay, so we have 5 squared is 25 times pi. It's going to give me 78.5398. So I'm going to write that in 5398. I'm going to leave it as 534 just because we have a lot of numbers now. 5 times 6 times 2 pi is going to give me 188.495. We're going to leave that as 5, right? Plus, that's going to be my area of my cylinder. So I'm just going to add those two together. 7 plus 188.5 is going to give me 267.04, right? Then I want to find the surface area of the sphere, and I'm going to do that in green, right? So let's do surface area of sphere, or half the surface area of the sphere. So I'm going to do half. Surface area of the sphere is just pi r squared. Sorry, surface area of the sphere is not that. it is equal to 4 pi r squared, right? So I know these two can cancel out. I'm left over with the 2, so I'm left with 2 pi r. And you could have just done 4 pi r squared, doesn't matter, times half. Do whatever which way you're comfortable. To me, it just makes sense to cross them out. So I'm left with 25 times 2 times pi. So I'm left with 50 pi is equal to 170.07. So I'm going to say 157.1, right? And I'm just going to find total surface area is just those two numbers added together. So I'm going to do 267.04 plus 157.1. And I'm left with surface area is equal to 424.1 meters squared. And that is my answer. Okay? Alrighty. So, moving on, we're going to do this last question together. These are the more complicated questions. Why would I go through easy questions with you in class? That's why I'm asking you to do your homework, right? So that you can get into the practice of how to use these numbers, how to think about them, right? But I am doing the thinking and inquiry type questions with you in class so that when you go back and you look at them, you know how to do the harder questions because you've thought about them. Okay? So now, volume, right? If we're thinking about the volume and we want to find the volume and surface area. So I'm always going to start with volume because I personally like finding volume easier. So I know the volume is going to equal, we have this inside area that if we put our hand through it, it would fit through. And then you have this outside area. So what we basically did, we had this sphere and then we cut a hole physically through it. So we took out a part of its volume, right? So we know that the volume is going to equal the volume of the big cylinder minus the volume of the small cylinder because we took that out and now that's not there anymore, right? I know that my radius of the big cylinder is 20. And I know that my radius of the small cylinder is from here to here, so it's 12. So I'm going to label this small r, and I'm going to label this big R. Okay? So let's just start putting stuff in. I know that the volume of a cylinder is equal to pi times radius, which we're going to say is big R here, squared times height. Minus, right, the volume of the small one is going to be pi little r, because we're using the small radius there, squared times height. Right, so let's just start putting our numbers in. So let's do, and I'm just going to use the same colors now. Pi times 20 squared, height is going to be 50 for both of them, minus pi times 12 squared times 50, right? So if I did 20 squared times 50, 20 squared is 400 times 50 is going to be 20,000 times pi is going to give me 62,831.853, so I'm going to round it up to 9. I'm rounding this up to the nearest decimal because we already have so many numbers to work with. We don't care about all those decimal places. Then we're going to do 12 squared plus 50 times 50 times pi, which is going to give me 22,619.46, so I'm going to round that up to 5. Right, and I'm just going to now subtract, and I'm going to be left with 212.4 centimeters cubed. Okay, so that's my volume. Now, surface area, always the more confusing one. So I just want to make sure that we know that surface is any area that you can touch, right? Any area that you can actually touch, like surface area, any surface. So because we took out the middle of this cylinder, we can now touch the inside of the cylinder. So we need to include that in our measurements. The other thing we did was we took out, we have this circle all around, so we have material used there, but we don't have anything in here. So we need to remove that inner circle from the larger circle as well. So the surface area is going to be the area of this space, the area of this inside space, and the area of this circle, the larger circle, minus the area of the inner circle, right? So it's a little confusing, but if you think about it logically, anywhere that's going to be able to need material is what is considered surface area. So I'm going to say, all right, surface area is equal to the surface area of the lateral surface outside or big. So I'm going to say big, right? Sorry. And then plus, right? Plus the surface area of the lateral surface inside, right? So you need to know the cylinder surface inside. Lateral surface small, right? So the smaller area. Plus, you need to know the big circle at the top, right? Plus, and there's two of them, so there's 2 times the surface area of the big circle minus the 2 cutouts that we did, minus 2 times the surface area of the small circle. So let's just start putting these in. And you can do them separately, or you can do them together. It's completely up to you. You can write a big equation like this, and you can put them straight in. Or what you can do is kind of how I like to do it. I like to give each one a color. So I'm going to do, this is going to be my purple, right? This one's going to be my yellow. This one is going to be my blue, right? And then this one's going to be my green, right? So let's solve them individually first. So I'm going to say, okay, surface area of the lateral surface. So let's do the purple one first. Surface area of the big lateral surface, right? So surface area is going to be 2 pi big R h, right? So 2 pi, the radius of my big circle is 20 times h equals 2, or sorry, h is 50, so I'm just going to plug that into 50. So 2 times 20 times 50 is going to be 6,283.2. Right, and then I'm going to move on to my yellow one, which is going to be the surface area of the small, lateral surface of the small. And that's going to also be 2 pi, but instead of big R, we're going to have small r, h. So 2 pi, small r is 12, h is still 50, it's the same for both. So 2 pi 12 times 50 is going to be 3,769.9, right? Then I'm going to do my blue one, surface area of the big circle, right? And you're going to multiply that by 2, equals 2 times surface area of a circle is just pi r squared, right? So I'm going to put that in, pi r, so the big circle area is pi big R squared, which is going to be 2 pi 20 squared. 2 pi 20 squared is just going to be 2513.3. And then I want the surface area of the small circle, so 2 times surface area of the small, right, is going to equal 2, and then I know surface area is just times 2 pi r squared, is equal to 2 pi 12 squared. is equal to 904.8. I'm just going to plug these numbers back into my equation. So I'm going to say surface area is equal to 6283.2 minus 3769.9 minus 2513.3. Sorry, plus. These are plus, right? Minus 904.8. And when I do all that math, it's all said and done. My surface is going to be 11,661.60 centimeters squared. Okay, and that's my surface area. And that's it. And that's that for this equation, or for this lesson. I will post these solutions.